Hey everyone, it's Alice here from Top Mark Science, and today we will be looking at floating and sinking. Throughout this video, we'll be exploring the forces occurring on an object in water, the interaction between forces in floating and sinking objects, and the factors affecting whether an object sinks or floats. Let's get started. Have you ever been on or seen a cruise ship and thought, how does it just not sink? Well, it's all about two key forces interacting between the boat and the water. The weight of the boat and upthrust, a force caused when the ship displaces water around it, resulting in the water pushing up on the object. We'll come back to this at the end. We'll start off with a little game of sink or float. If I put some objects into water, try and guess whether you think it will sink or float. Starting with an iron nail. This would sink. A carrot? This would sink too. How about a ping pong ball? This floats on the surface of the water. What about broccoli florets? These can float too. How about a metal spoon? This sinks. Or a plastic spoon? It floats. What if I push the spoon under the water to the bottom of the water bowl? Well, when I let go, the plastic spoon would rise up and float at the top. So what is causing various objects to sink or float? Well, they all have gravity acting on them, so their weight acts down on the object. But some of them have more weight than others, so more downward force, compared to the upthrust force. Look at the carrot example again. You can see that weight is greater than upthrust, giving a resultant force acting down. So the net movement, the overall movement, means the carrot moves down. It sinks. Whereas the broccoli florets have balanced forces where weight is equal to upthrust, meaning there is no resultant force, so no net movement. They float. Going back to this example then, if it's submerged in water, surely it stays underwater. Well, in this case, the plastic spoon's weight is not enough and upthrust is more. So the spoon rises due to the resultant force on the spoon acting upwards, until the spoon reaches a point at the top where these two forces now balance each other and the spoon can float. Pause the video here for a learning checkpoint. For each force diagram, determine whether it will sink, float or rise. Then have a go at the second task, and if you finish, try the challenge. Let's go through the answers. Marking pens ready. In diagram A, the arrows are equal in size, and so the forces are balanced. This object can float. In diagram B, the upthrust force is greater than weight, so the object rises up. Diagram C shows weight is greater than upthrust, causing the object to sink. And D shows larger forces but are still balanced, so we have an object with more weight floating. Now looking at these pictures, we'll draw the forces diagrams for them. Rubber ducks are supposed to float, so the forces should be drawn balanced, shown by arrows of equal size. Anchors are designed to sink, so weight should be larger than upthrust. Life jackets are designed to float, so these arrows should be the same size too. Let's look at these two spoons again. As we saw earlier, our metal spoon sunk while the plastic one floated. The same object, but different behaviours. This all comes down to the density of an object. Density is described as the mass per unit volume, so this metal spoon has more mass in the same space than the plastic spoon, which has less mass in the same space. So the metal spoon has a greater density, leading to a favour in the direction of weight, hence sinking. Whereas the plastic spoon is less dense, and so weight is not favoured, leading to a rise and float of the spoon. Time for some independent practice now. Use the words in the pink box to fill in the sentences on the screen. If you can, it's useful to copy the sentences for future use. If you finish, try the challenge. Let's go through some answers. Fill in any words you missed as we go. Objects in water experience two key forces: weight, which acts down, and upthrust, which acts upwards. If an object's weight is greater than upthrust, the object will sink, and if an object's weight is less than upthrust, the object will rise. If weight and upthrust are balanced, the object will float. Well done if you got some or all of these correct, guys. And the challenge was to explain what would happen to you if you were to go in the Dead Sea, sink or float. Well, there is a higher concentration of salt. This increases the density of the water. This pushes upwards on an object with more upthrust, making it easier to float in the Dead Sea. So back to the floating ship. The boat's weight causes displacement of water. It pushes it out the way, causing an equal and opposite force of upthrust to act back up on the boat. These forces are balanced, hence the ship can float. Good job, everyone. Let's have our end of video quiz to test our knowledge. Question 1. If weight is greater than upthrust, an object will sink. Nice start. Question 2. For an object to float, weight and upthrust must be balanced. Excellent. Question 3. What factor can affect two objects that are the same, but one floats and the other sinks? For example, a golf ball and a ping pong ball. It's density. Tricky one, but well done. Question 4. True or false? The resultant force on a floating object is 0 newtons. This is true. The forces are balanced, and so there is no overall force in any direction. And finally, question 5. Draw a force diagram of a sinking pen with a weight of 10 newtons and upthrust of 5 newtons. Calculate the resultant force. Your diagram should look something like this. The weight arrow pointing down should be larger than your upthrust, labelled like so, and a resultant force of 10 take away 5 newtons, which is 5 newtons downwards. The pen is sinking. Pause the video here and take a minute or two to rate your progress of this topic. Thank you so much for watching this video, guys. If you enjoyed this video and would like to see more from Top Mark Science, you can like this video and subscribe to this channel. I'll see you next time.